special events, of which there's quite a few coming up. There's no hacking workshop this Saturday because we have a competition, and therefore I don't have any Saturday class. I'll be at Stanford, sitting there as a useless mascot, but they like to have me present at these competitions. But we do have a guest speaker coming up in a couple weeks on a Monday, so that would be fun, and there will probably be food provided. There usually is. So you might want to go to that. Anyway, those are the upcoming special events.
Question?
Yeah.
When is that speaker?
On the 17th, on Monday evening.
Monday?
Yeah. Oh, I should say 6 p.m. here. I got to add that back in. Yeah, it's 6 p.m.
This is your main page, okay.
Yeah.
Okay.
Yeah. All right, anyway, good. All right, so here we are on 128, and by the way, as I warned you, the second half of the semester goes really fast. There's only a few classes left. So today we're at 11.5, and we're going to talk about Chapter 9, and then we'll go back to Chapter 2, which we skipped, which is iOS, which I put towards the end because I can't really have any hands-on projects with iOS because there is no iPhone simulator that works and is free and available. So anyway, let's start with Chapter 9, which I should have running someplace, and here we go. All right, so this is basically a summary of everything that's gone in the previous couple chapters from the other side. We talked about all the attacks. Here's how you write this is the security recommendations to employ this. So the vulnerabilities we know, you can inject code, you can have logic flaws, you can have insecure storage, communication, or logging, or errors in the configuration, like unnecessary permissions. So here's general principles to make a more secure app. One is the principle of least exposure. This is an idea that you really shouldn't let your app accept data any more than it has to. This is called the attack surface. What are all the ways that data could flow into your app that might be an attack? And you should close the ones you're not using, just like you should close network ports you're not using. So those are all the entry points. And so you want to remove the ones you're not using, and you want to put security checks on the ones you are using. So therefore, you shouldn't export more components than you have to. The most secure app has only one activity exported and nothing else, and that's the launcher activity. So you can launch it. Of course, you may have reasons to expose more, and you usually do, but you should consider why you're exposing things and not expose unnecessary things. You should avoid storing sensitive data like passwords. If you do store it, the SD card is even worse than storing it in the app's individual directory. But if you really need to store a secret, a much better place to put it is in the Android key store, of course, not in the app's directory. And you have inputs, SD card, internet, Wi-Fi, Bluetooth, all these things are feeding signals into your phone, and they can all bring in attacks. So when you get any data, you should verify it. This is the zero trust principle that we're all supposed to be moving towards. Anything that comes in, don't trust it. Instead, verify it. If possible, have some like encryption signature on it. If you can't have that, then do some sanitation check. Make sure it's not too long. Make sure it doesn't contain special characters, things like that. Do some test to make sure that the data you got is not harmful. All right, and if you run data code from some untrusted location, then you have to be very careful. That's risky. I say cryptographic protections are the best. If your code can be signed with a cryptographic signature, then you'd know it's intact and unmodified. Don't have more permissions than you need. Don't put in permissions like install packages unless you have to do that. You can add extra files to the APK. The APK is just a zip file. It contains files and folders. Sometimes people accidentally include configuration files that include secrets, like passwords and such. And that's, of course, unsafe. So security mechanisms, here's functions you should trace. On create is when it first launches. On receive is when it receives some data. Content provider, these are the things that affect the database. And here's things that launch a service. And those are things that could be coming in a malicious way. So those are functions you should consider how they're used and put controls on to see if their launch has been malicious. And your exported components should have limited permissions. Usually you only make them available to apps from the same company. Unless you really want to offer a component for public use, like you're a browser, and you want to open every URL in it, then you should be careful and consider that the data may well be malicious coming in. Your activities are the visible pages you can launch. Now your apps go in the recently used apps list, and they have a sort of small thumbnail you can scroll through, and you might worry that that thumbnail would include sensitive information. Some people worry about that. So if you want to, you can replace your the little logo of your app with a blank screen, or you can even remove it entirely from the recently used apps list if you want to do that. And tap jacking, we talked about, this is also called UI redress, where you draw a transparent picture on top of the image, and so the user thinks they're clicking on one thing, but they're really clicking on something else. Yeah.
How is tap tracking different from what we talked about earlier with people clicking the X, but actually that's them clicking permissions?
It's the same thing, just another word for the same thing. Yeah, that's the trick. You trick them, you give them a confusing user interface, so they're doing something that they think they're doing something else.
Oh, it's the same thing.
Like they think they're playing a balloon game to win a prize, but they're actually clicking on, okay, install this app. Yeah, so, and there's a dictionary, you can control this. The phone will remember words you've used and add them to the dictionary to check the spelling later, and you probably don't want them to remember the password and offer it in like emails and stuff, so your input type can have a label in it to tell it not to put this in the dictionary. Fragments are probably not really an issue anymore. They were in earlier parts of the page. I use fragments. For example, if you go to this page, here and you click projects or slides. There, see, I put pound lecture up here. You can do this. You can put anchor tags on an HTML page, and the fragment, which is the part after the pound, will jump to a named location on a page. So it's a common web feature, but it turned out to be dangerous in Android apps. And people would use them to inject code and fragments and stuff. So they've been pretty much blocked by default since Android 4. Anyway, there are ways to allow them in, but I don't think anybody's using them anymore. In general, you want to have security boundaries, and if you take the web app course, they talk about this. You should consider your security boundaries and check anything that goes across the boundary to see if it's malicious. So make sure there's no way to open an authenticated activity from unauthenticated areas of the app. If you have parts where you've logged in and parts where you haven't logged in, you have to keep track of when you're moving from one to the other. This is the most common place where something goes wrong. There is some path from the unlogged in state to a confidential thing without passing through the login state. It's easy to make that mistake. And here's the thing that will prevent a password from being displayed on the screen. It'll just show dots as you type it in. And browsable activities are the ones that can launch from a URL with a scheme : / and then some data. So if you use this, then you have to consider all the possible data that could be sent in from the outside using that format. Content providers are the databases. They used to be exported by default, although I don't think anybody's using phones this old very much. Now they're not exported by default. And as you know, they're subject to SQL injection, like all databases. So you should use prepared statements like this, where you have data coming in from the user, where it's going to search for products where the type of data is something that came from the user. You use this kind of structure where it's just a placeholder and a placeholder here, and then you feed in the data from here, so that the data is not put in a line of text which is parsed trying to match apostrophes. It's just fed in as a data object into a template, so it cannot be misinterpreted as a code object. Directory traversal is an issue where you take a file name and you let the user put in things like .. / and they can navigate to a place they shouldn't be. So what you should do before using any path that came from the user is use the get canonical path method to to resolve all the up and down and give you the exact path, and then you can compare it to see if that path is acceptable. So here, for example, in comes a path from the user, gives me a URI. So down here we get the canonical path and then make sure that it starts with the base folder, that it's in the right folder, and otherwise it won't run. That's what you do. All right. And you got pattern matching checks. We saw this before. If you define permissions, you have to be careful what you're doing. If you use path, then it would apply to here, but not subdirectories. And so there are different ways to express permissions, and you have to read the documentation and make sure you're doing it right, or you'll have that mistake that we had with that Civ app, where just adding a slash to the end meant the permissions no longer applied. Apache configuration files have a very similar structure that often makes a very similar mistake. All right, and then a lot of people have secret codes that are defined in the Android manifest. You can have the secret code up here. And in general, they're not very secret because you can just see them in the manifest. This is the thing, the fundamental flaw that most Android developers do not understand is that you're handing out the source code with your app. That's not obvious, but now we know that's true. You can totally read the Smalley code. It's almost as easy to read as Java. You can even use GADX to turn it back into readable Java. All the constants are there, all the branching. So, you're not able to hide anything. And so the secret codes are easily enumerated, so they say you can't trust them. So let's try Kahoot. It's 9A, and no comments. Okay.
Love these things. Don't say that again.
You say you love these things too now, or just think he loves them? Okay.
Always.
Well, the first couple of weeks you didn't love them, but you got to love them anyway. Most people like them, but you can ignore them if you don't like them. That's part of why they're extra credit. Yeah. But some people don't like the be in a hurry and stuff. And, they're not incredibly fair. Like somebody could be watching, asking somebody else how to answer them or something. So I certainly wouldn't use it for real tests. But a little bit of extra credit is fine.
Dang it. I thought we only three of us.
That would be the easy way. There's 14 people online, so there'll probably be a few. Usually about half the people seem to come to this. Sometimes there are only 3, but not in this class. This class is kind of big. My Python class, I even quit doing this for the introductory one because not enough people are interested. But I think it's a beginning course, and I think coders are kind of demoralized right now. They probably don't feel like there's a job available for them for pretty good reason. I think morale is kind of low in the coding courses. Let's give it a try. All right, so which defense stops tap jacking? Yep, that's it, called filter touches when obscured. So it cannot be, it will not accept touches on top of something that you can't see. That seems like that should be the default, but anyway, there it is. All right, what component might allow fragment injection? Boy. Okay, fair Oh, I thought it would be broadcast receivers. Let's go back and look at the slides on that one. Let me see if I can understand it. That was fragment injection. An activity can contain a fragment. Okay, fair enough. It's part of an activity. That's surprising. Okay, fair enough. All right. All right, how do you stop SQL injection? This applies to every form of SQL, including the kind used in Android. Yeah, prepared statements. That's what you do. All right. And what path permission fails to protect subfolders? Yeah, that was it. Path is the exact match. These other ones, path prefix and path pattern, are the ones that will apply to a bunch of paths. This one applies to just the one exact path you're protecting. This is usually not what you want. Good. Let's go back to here and proceed. So, yep, we're on time. All right, and then files. You got to store your files somewhere. So, yeah.
Is this more slides or was it on that?
What's that?
Never mind.
Okay, all right. So you can set permissions for your files, like they're more private, the mode is private, and the directory is private. You can encrypt them. You could write your own encryption algorithm, which a lot of apps do. I don't much recommend it. Well, they download libraries and use them. If you're using AES, is a symmetric encryption that's plenty strong if you avoid electronic code book. But the problem is, where are you going to put the secret key? If you hide it on the phone, I'll be able to find it. RSA or something long, 2048 or longer would be better for asymmetric encryption. Anyway, random is a problem in every language. The easy-to-use default random number generator is not good enough. I don't know why everyone keeps doing this. Even in modern languages like Java, they give you an insecure random number generator by default, and you have to go get a secure one somewhere else, so everybody keeps making the same mistake. And this one here produces the same series of numbers each time it's run from the same seed. So it's kind of ridiculous. Secure random is the better one you can get. So if you make a utility using random and then run it in a Java sandbox, you'll see every time you run it with the same seed, you'll get exactly the same series of numbers. It's very weakly pseudo-random in that regard. So PVKDF2 is a way to generate a key from a password, which is considered quite secure. What it does is you do a whole bunch, you add a salt to the password, some random letters, and then you run it through a hashing algorithm a bunch of times. And you take the first number of bits of that, and that creates a key. So this is a way to create a key. If you want to save the key, you should save it in Android Key Store. If you want to let other apps see a file, then you have to they're going to have read-write permission, and then they can only access this folder. So here's how you do it. You force the permission to be there, and you specify the path prefix to be document. So everything that starts with this, it applies to, and that will give you some ability to share your file in a controlled way. And for secure communications, of course, you shouldn't be sending anything over HTTP. Almost nobody does anymore. HTTPS is better, but the certificate authorities can be forged or stolen, and it happens sometimes. Certificate pinning makes it even safer, where you require specific certificate authority. All right, your local communications to move data from one app to another. The Android API has intent filters you can use to send a signal from one to another. There are other ways to do it. You can use network sockets that listen on local hosts. So it technically is networking, but it doesn't go out of the phone. You can also use the clipboard to move data from one to another, but those are less safe. And then WebView, of course, lets you open a web page in an activity, which is often very useful to make it pretty, but of course you're going to have trouble there. So disable JavaScript if you're not using it. We talked about the vulnerabilities of this. Use HTTPS, don't load anything over HTTP. And don't use JavaScript interface. That's really dangerous. That's the one that downloads dynamic code from the web and runs it, so you don't even know what code is being run. And plugins are deprecated now anyway. Don't let it access the file system. All right, and validate the content. These are good policies for whatever you're opening there. And the Android manifest is where you have all the permissions. You can determine whether to allow backups and debugging. This is a project I'd like to add to this course. I haven't found a good project yet where you debug an app. That's a new way to hack into an app, is to debug it. I'd like to see that. I haven't quite figured out how to get it working. I may have time to try and get it working this semester. But that would be another interesting attack. But they say don't make your app debuggable, your distributable app, because that gives people a way to peer inside your app and steal secrets. And of course, you specify the SDK version, and you don't want it to be too low, but you just need to find out what versions of Android are still usually reasonably in use. Android 9 gives you a lot of good things. DNS is encrypted, network traffic is encrypted unless you explicitly set it to be clear text. separate web view directories for each process, so one process can't steal cookies from another. So those are all pretty nice. So it'd be nice if you target at least Android 9. I don't think very many people are using Android versions older than 9, but I haven't seen a recent chart. I know a few years ago some people were still using Android 4 and so on. You can also use 1111 on Android Pie. You can add an app here. Cloudflare provides it, which is encrypted DNS. And they also give you a free VPN, by the way, which I added to the incident response class. There's a free VPN called Warp from Cloudflare that you can put on phones or any other device, and that's a nice security measure. Anyway, you shouldn't be logging anything in release builds that is considered to be a good idea, and ProGuard can remove it. Native code written in C or C++ and compiled down to real assembly code is considered difficult to secure. It has a whole bunch of C problems that we talk about in the exploit development class: buffer overflows, format string vulnerabilities, heap buffer overflows, integer overflows. There's a whole bunch of problems caused by the language C. So if you're going to use them, then there are a bunch of defenses to protect native code available. This relocation read-only prevents you from changing the global offset table, which would change the location of system routines. So you can make a system routine run Trojan code. You can prevent that with this defense. Run path is a defense that prevents attackers from loading libraries from an unexpected location, so they can put in malicious libraries. And there are other defenses here, like a non-executable stack and a stack canary that prevent them from running code they've injected. So anyway, those are standard security mechanisms in every operating system, and they're available in Android too. And so here's another, I used to have a project on this one, but it was really sort of complicated and only applied to old versions. But you could load an app and define a permission, a malicious app, and then when people put in the real app, it'll say, oh, that permission already exists, and it will inherit the permission level from the previous one. So that's a nasty thing. So your app can check to make sure protection levels are intact at the entry point. That's called a protection level downgrade. And if you have non-exported components, attackers with root permission can still access them. We did that if you have root, but you can actually add a token to prevent that. You can require a authorization token, so even root can't get in unless they have a token. I've never seen an app that does this, but it might be a good idea. Just like you have an authorization token for web requests. So then you can do things that just irritate reverse engineers. Since you have your source code, you can't really stop anybody, but you can slow them down. The obfuscation is common. Like I talked about ProGuard. ProGuard changes a bunch of names of methods to A and B and C and stuff like that. But in practice, it's useless because it doesn't seem to change anything that matters. DexGuard is the paid version. I've never tried it. Dasho is good. It's expensive, but it had like a 15-day free trial. So I tried running it. And here's what it does. It changes every variable and every method to garbage like this. Now that will slow you down, although I've totally hacked into apps like that. What you have to do is I write Python scripts that Trojan every method with an entry in the log that says, I'm entering this method, I'm entering that method, I'm entering that method. Then I run the app, and it runs really slow with the log screaming by, and then I go to the login, and I find out which method is handling the login, and then I Trojan every variable in the login. You can still get in, but it slows you down. You know, it's a whole lot harder than being able to search for like password, and there it is. So, you know, all right. Then there's root detection, which everybody should really be doing. You should be detecting if it's running on a rooted phone, and don't let it run. That's a simple measure to slow down reverse engineers. And there are various packages, there are various clues that it's rooted, and there are clues to detect that it's in an emulator and not run. And I've been told that Android malware does this. So you cannot teach an Android malware class with these emulators. You got to have real devices. Because the malware won't run in emulators. Because the malware people are interested in this form of security, even though the commercial people don't seem to care. They don't want people to be able to easily reverse engineer their malware. All right, and you can also detect whether the environment allows debugging. Like I say, I haven't ever tried debugging. I'd like to add it to the hands-on projects, but it's not there yet. And then you can, of course, check for tamper detection, which we did in the project. You can check the signature, you can check the hash of the app, you can do something to see if the app has been modified, and that would be nice. Almost nobody does. But it would, just like detecting rooted phones, Those are good, simple defenses that would make the apps a lot more secure if anybody cared. Anyway,
Another Kahoot?
what's that?
Looks like you're gonna do another Kahoot now?
Another Kahoot, precisely, 9B.
Okay.
Let's try this again.
That's right.
Professor, only yelled on the video board once. At
Oh.
the same time, it's more than 0.
Well, it's that's what makes video games fun, is that they're tough, same thing. He made it, I think he won once, yeah, a couple of weeks ago.
However, I am also a firm believer in the concept of I pay $59.99 for this game and go over and manipulate all the variables I can.
That's good. Now, Caitlin actually hacked into this thing one time. You can run a script that creates like 10 accounts and then automatically gives every answer instantly, so one of them will win. It's incredibly obvious. You have like 10 or 100 extra students in the game, but you can do it. It's not a very effective attack. It's not like you're not going to notice. I'm not aware of an effective way to hack it because you don't know what the right answer is. I mean, you can make something that answers quickly, but how could you make it get the right answer quickly? Yeah, or you'd have to go look at last semester's videos and prepare the question. Another way to do it. Anyway, low-tech attacks would be effective. All right. Let's give it a shot. All right, so what defense will prevent a stack overflow in native code? That's what a canary value is. A canary value is placed at the end of the stack frame, so if you overflow a string, it will hit the canary and stop the app instead of letting it continue to run.
At the end of the string, you said?
At the end of a stack frame, before the return value. So the way you take over a app with a buffer overflow exploit is you find a string variable and you put in too many characters so it overflows it, and you hit the return pointer, which shows where it should go back to when it returns. And you can cause it to return to some other location, which gives you control of the box. But the canary is added at the end of the variables before the return pointer and verified when you try to return, so that the app will refuse to return if that number has been modified. It's a quite effective defense, and it's in all modern operating systems. All right, what function creates a key from a password? Very handy. This is it. It stands for password-based key derivation function. That's what it is. All right.
You won the game right now. Really
Good.
tense.
All right. And what defense makes Smalley code difficult to read? That's obfuscation. You just change all the names to meaningless garbage, and that's harder to read. It's not an absolute defense, but it's an obstruction. All right, and what mechanism make HTTPS more secure? Oh, that's Pinning the certificate means it has extra information beyond normal validation to make sure you really have the right certificate. All right. Steve again, good. Austin again. Same people, all right. All right. All right. Let's stop this recording.